Hello all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript, our Jigsaw puzzle game. Well, I was going to show you how to create the unit test for the graphical part of the game. You know, the image itself, the puzzle pieces, and all that kind of fun stuff, but I realized that we have nothing to show. No HTML, no CSS, no nothing on the screen. So what we're going to do today is we're going to do a proof of concept that will show you how to load up an image, how to cut it up into different pieces, how to shuffle the pieces, and how to move the pieces around the board. Now, because this is a proof of concept, we're going to basically sit there and just have a hard-coded 16 pieces to the puzzle, each piece being a perfect square, and we're going to have a puzzle that's going to be smaller than what we call the drop zone, which is where we're going to be able to move all the pieces around. So, you know, it's going to be very simple, but it's going to give us enough to be able to go on that we can then, in another video, create the graphical unit test. So let's get started. We're going to first need to put in our HTML. So that's going to be something very simple. Let's create a HTML file. We'll call it index.html. So let's pop the HTML in there, and I'll just show you very quickly what we have. And it's very, very simple. What we're going to end up with is on the left-hand side, we got a bunch of actions, which we're going to be able to select the image, select the number of pieces, select the cut design. That'd be like, you know, if we eventually wanted to say square or circle or hexagon or whatever, you know, it doesn't really matter. This is going to be a hidden file, which we're going to be able to, I'll show you how that works to be able to select our image. And this is just two little pieces down here. I've got hard-coded to be able to say, hey, this is the number of pieces we're currently going to be working with, and this is going to be the cut design. Now, what I will do here is I'm going to, just to get things rolling here and make things easier, I'm going to hard-code for 16 pieces and hard-code for a square cut design, but I'm going to still show you how that works. This is going to be our board. And our board is basically going to be a black square in which our puzzle is going to get loaded into, and all the pieces are going to get shuffled. This is a temporary canvas that we're going to be using that to preliminarily load the image that we get from this particular image input into our temporary canvas, in which we can then split that up into all the different pieces. And this is these are two dialogues where we do the cut design and the pieces itself. I'm not really worried about that. And here's our jigsaw puzzle.javascript file that we're going to use. So, you know, if we were to take a look at it now, we're inside of our live jigsaw puzzle. So we'll do npm run dev. And it says the following dependencies are imported but cannot be resolved, of course, because we haven't created it yet. But let's just see what that looks like. And that's what it looks like. You see, there's absolutely nothing to it. So let's go ahead and pop in our CSS, because that's going to be something very, very simple to do. Underneath our source directory, we're going to create a directory now called CSS. And we're going to create a post CSS file called jigsaw-puzzle. And why post CSS? Well, that's going to be what CSS will eventually become. So I'm not going to be doing simple, normal CSS here. I'm going to be using post CSS. That is a new CSS standard that will eventually come into CSS. So you might as well go ahead and get used to it now. So we created the puzzle CSS. Let's throw the code in there. You know, save you from all the typing. Enter the magic of television. There it is. Woohoo! And it's no big deal here. Turn the background green, flexing, you know, doing our buttons. The big thing here, the board is positioned relative, and we got top left of 0. Our cut is sit here. Each cut has a span. Each one of these spans is going to represent a puzzle piece, and we'll go over this a little bit more detail once we start getting the pieces done. Okay, now that we got that done, let's go ahead and pop our JavaScript inside there. So we're going to create a source directory. Nope, we already created a source directory called JavaScript. So let's go inside our JavaScript, and we're going to create a JavaScript file, and we'll call that JavaScript file jigsawpuzzle.js. And as you can see, it's nothing there. So let's go ahead and start popping some code inside there. I'm not going to throw the whole thing in there at one time. First thing I'm going to do here, this is the way Vite works, is I'm going to import the PCSS file straight in from the JavaScript, from the Jigsaw puzzle file. And this is basically what Vite will do, is once it takes it, it will compile it into the distribution part, so it'll be automatically loaded up within the HTML file. So that should get our That should get our file looking better. Let's see. And it does not. That means I've made a mistake somewhere. Failed to load resources, jigsawpuzzle.js. Okay, so what did I mess up on? Okay, after a little bit of wailing, gnashing of teeth, there we are. That's what should be done. We'll fix that problem. So as you can tell here, I've got the select image on the left-hand side here, the select number of pieces, select cut design, and go. So let's go ahead and add in let's go ahead and add in the event listeners for all 4 of those. So let's start with the select image because that's going to be a very important one to do. So the first thing we're going to do is we're going to get pointers to all the different pieces on our HTML, which is very simple. You know, basically we're going to do just gate element by ID. I love putting IDs on absolutely everything because it just makes life a whole heck of a lot easier. So for instance, this whole section up top here is basically pointing to our images, our board itself. This is going to be the Jigsaw puzzle board. This section right here is the buttons on the left-hand side of the HTML. That will give us all the pieces we need there. Here's where I'm hard-coding the number of pieces because I don't want to go through all the dialogues. This is pointing to all of the different dialog boxes that we're going to be able to use when we select the cut piece number of cuts or the type or the cut design. We're not going to really use those at all. Here's the go button at the very bottom. Here's a selection to here's a pointer to our cut, which is going to be this cut right here. And that's going to hold our actual puzzle. And a lot of this will make sense once we start getting the information in there. So let's go ahead and first put in some information here. We're going to do a select. We're going to first of all go to our select image because that's going to be our first very important piece of data here. Because once we click on the, let me bring that up here. Once we click on the select image button, we want to be able to go somewhere. In this case, we're going to go to Jigsaw image click. Now, what's Jigsaw image? Jigsaw image is our Jigsaw image ID. And what is our Jigsaw image ID? That is right here. So what we're going to do here, we got this type. Type file input hidden, and we're just going to be able to click on it to be able to activate the internal dialogues for the browser to be able to allow us to select any kind of image file from the system. What happens once that is done? Well, let's find out. When we have a Jigsaw image click, the next thing we're going to need to do is we need to have some sort of event listener to be able to tell us. Let's add that in. Some sort of event listener to be able to tell us that we've got an actual input, and that's going to be a input event. Once that input event has occurred, then we know that we have done we've actually selected a file within the dialog box, and you'll see that here shortly. And this is very simple. I basically stole this from Mozilla Developer Network. We're going to be able to create an object URL, and we're going to create a new image, make that as the source, and then once it finishes the onload here, we're going to basically take that image, and we're going to draw that image into our temporary canvas. Once we draw it into a temporary canvas, we're then going to take the image from the temporary canvas and draw it into another image. And the reason we're doing that is that this particular file is something like 720 or 730 pixels by 730 pixels. I want to get it down to 500 by 500, and then basically this scales it. So inside the image file, which is right up here, that image file is going to already have the 500 by 500 version of our picture instead of the 500 by 500 version picture instead of the 720 or 730 or however big it is that it is on the system on our hard drive. So that will take care of the Jigsaw image and getting the input itself. So what else do we need to do? Well, let's just do something very easy here. I'm not going to worry about the dialog designs. I'm looking through my code here. The big thing we're going to need to do now is we're going to need to actually do the go. So when we click on the go button, we're going to need to basically do a go. So let's add some code for that. Okay, so here's our go button, and we want to add event listener click. When I click on it go, basically what I want to do here is I want to initialize a board, and then I want to cut pieces, and then I want to shuffle pieces. So let's take a look at all that code very quickly here. So let's take a look at that code. Here is the initialized board. Initialized board basically is just something simple I want to put inside here. So as I'm doing this POC, I can initialize any kind of variables, and I'm setting a style on a height and a width. But notice I got a variable here called puzzle.boardWidth, and what that is some default values that we need to add to our system. So let's go back to the very top. Let's add those default values in there. And this is basically saying my puzzle width is going, and height is going to be 500 by 500. The board, where we're going to drag and drop, is going to be 700 by 700. Rolling Z is going to be interesting. I'll show you that here in just a second. And this is going to be representing the piece that we're going to be moving as we do the drag and drop. So that takes care of all that. Cut pieces. So on the cut pieces, let's bring up that code. Through the magic of television, there's cut pieces. And so what does cut pieces do? Well, cut pieces, then again, this is also kind of very much hard-coded to, in this case, 16 different, 16 pieces, 4x4. So a lot of this cut pieces will physically take that particular image that we had within, where do we put that image? Take this image right here, and it will split it up into 16 different pieces. And those 16 different pieces we put into 16 different spans. So let's take a look at that code. I'm going to erase this. I just realized I don't need this part anymore. Here's I got extra parentheses there, so it's going to look weird, but that's okay. I'm not worried about that. So the idea here is that what we want to do is we're going to try to figure out how many rows we're going to have and how many columns. So just taking the square root. Since I know it's going to be 4x4 in this case, I know that rows and columns are going to be 4. And then I'm going to try to figure out what the height of the span and the width of the span will be. Now, why? What's going to happen there? So what will happen inside our HTML, inside this section right here in the cut, we're going to put a span for each of the different pieces. So each piece will have a span element. Within that span element will be a canvas piece, and that canvas piece will hold the little section of the puzzle. So what we're going to do is we're going to take that big image that we've downloaded. Let's bring back this. We're going to grab this image that we've downloaded, and we're going to split it up into 16 different pieces, and each there's going to be a canvas element per span that's going to have each of those individual 16 pieces. And so that's what this does. Well, first of all, what we're going to do is we're going to, if we're running it again, we're going to get rid of anything that used to be there. But we're just going to do a simple for loop for the R and the C to go from 0 to the number of rows, or 0 to the number of columns minus 1. We create the span. We're going to set the span height and width, because each one's going to be the exact same height and the exact same width. We're going to set the top and the left. So if you think about it now, we're building up our own little grid here by saying R, the row times the span height, and this column times the span height. What we're doing is we're putting 16 pieces into a 4x4 grid, and we're basically building our own grid. Give it an ID. Here's where we create the canvas element, and we're giving the canvas element the same thing with the span width and span height. And here is the fun part. We're going to create our context within the canvas, and then we're going to use the draw image of the routine within the context to be able to splice out not splice, but copy just one tiny section of that image into our canvas. Basically, this is our source image, which is what we loaded up right here. Our source is image. Where we're going to get it from is, this basically is what's the X value we're going to get it from. This X value is going to be the current column number times the width. What's our Y value? It's going to be the current row number times the width. What's going to be the size that's going to be the starting XY point. What's going to be the width and the height? That's going to be our span width and span height. And then what's going to be the destination? Well, the canvas is going to take the whole thing, so the destination is really easy. The destination will always be 0, 0, upper left-hand corner, with the canvas width and the canvas height. And we could have used span height and span width here too. It doesn't really matter because it would be the exact same number. But the idea here now is that we're going to grab this image and automatically try to target one of the 16 different pieces of the puzzle inside this image. If you can think of it as gridded out into 16 different pieces, we're going to target each one of those pieces and throw it into our context. Once we throw it into our context, that's going to put that particular piece of the image into our canvas. So all we have to do is append the canvas to our span and append the span to the cut. And that will basically now cut all the different pieces. Then we're going to need to shuffle the pieces. But what I'm going to do real quick here is let's see if we got everything that we need. I'm going to just comment that out just to kind of show you what the screen's going to look like. So let's save it and let's find out if we've actually gotten everything correct. So we're going to select our image. Actually, what I want to do here is we're also going to bring up, well, let's just do that first. We're going to select our image. So there, our image is inside FWJS Jigsaw Puzzle Source Image. Obviously, I've run this before, so it's automatically pointing to our sample image. We click on Open. What happened? Well, nothing's happened because, you know, we haven't hit Go yet. Once we hit Go, everything should appear on the screen if we didn't forget to cut, copy, and paste something. So we go, go. It worked. There it is. Did we get any errors? Oh, we didn't get any errors. Hot dog. There we are. So as you can tell here now, we've taken the image and we scaled it down to 500 by 500. Our board is 700 by 700. So our board, which is what this big, large black area here is where we're going to be able to move all these pieces once we get the section in there to be able to move the pieces. But as you can tell here, each one of these pieces have been split. And I've got a little black line between it. And I just kind of want to show you that. What I realized is that used to be a border, but I found out that when I was using a border here, obviously a border takes up an actual pixel on the span. And so it was kind of messing up the image in that case. So what I did now is I kind of cheated it and put a box shadow there around the span, because the shadows don't take up pixels. It just is a nice little shadow around it. But this little trick here gives me the ability, to put a little border around each of the spans without actually taking up any kind of pixels, and that works like a champ. As you can tell, I've got what appears to be a border, but there is no border. If everything is actually, we got the just nice, pretty little shadows around all the spans. So once we get to the point where we can combine pieces together, which won't be this video, then we will then put the shadow around both of those pieces, and everything will eventually look nice and pretty. So believe me, works like a champ. But as you can tell here, we were successful. We've now split up into 16 different spans. In fact, let's just inspect that real quick. And there you can see it. There we go. There's our 16 different spans. Each span has its own canvas. So that will basically allow me now to be able to, actually I should be able to do that. Yeah, there we go. You can see it kind of flashing in the background there as I hover over. So each span contains a particular puzzle. Each span contains a canvas that has a 1/16 of the puzzle itself. Let's shuffle it and see what happens. So let's put the code in there to shuffle. And that's real easy. I'm just going to the cut itself, and I'm taking all the children. I'm going through each one of the pieces, and I'm going to do a random X and Y, and I'm just going to set the style top to X or Y. And I'm doing the random with the board width and the board height from 0 to basically the board width and the board height minus the size of the piece itself. So that will ensure that the piece doesn't go off in the left-hand corner somewhere. So that will ensure that everything is staying within the black area. So let's put that back on, do the shuffle pieces. Let's bring up our code, do the select image, sample, open, go. And they're shuffled, yay! Hot dog, that worked. So the last thing I want to do for this video is I want to actually put in the drag and drop operations to be able to drag all of these different images all around the board, because eventually what we want to do is we want to be able to drag the images. Like for instance, I want to take this image right here, if you can see my mouse, and move it over to close to this image, because those two will should go together, or maybe that one, I don't know. One of those will go together, doesn't really matter. So once we do that, you know, I want to be able to get them close enough to where they will combine themselves, you know, because they connected each other. So to be able to do that, we're going to need to be able to drag and drop each of the different DOMs. And it's real easy. Basically what we're going to do is we're going to, when we detect a click event has occurred or a mouse down event, we're going to basically say, okay, what canvas element has been clicked on? Because it's going to be the canvas elements that are going to be clicked upon. Once we clicked upon the canvas element, we're going to activate the mouse moves and activate a drop. And once that happens, as we move the mouse, we're going to set the value of the top and left value of the CSS on the styling for these particular span elements as we move the mouse. And so by doing that, the element itself will, or the element, the span element will move along with us. And once we let go, it should automatically just stop and place that span element when we left it. And of course, we're also going to take into account, what happens if we go in and out of the black area, do we have to take that into account? And the answer is yes, we're going to need to take that into account. So let's do that. Let's pop that code in there one piece at a time. Okay, first of all, we're going to have the board. That's going to do the add event listener. We're going to do the mouse down. If the target is an instance of HTML canvas element, we're going to start the drag, and that's basically allow us to click on anywhere within the entire board. And if we don't click on a canvas element, then we don't want to do anything, because obviously I don't want to click on the black area and move the whole black area. I just want to move the pieces itself. So we're going to need a routine called start drag, which is going to start the dragging process. So guess what our next routine is going to be? You guessed that right. It's going to be start drag. So let's throw that in there. Okay, here's our start drag through the magic of television. First thing we're going to do is we're going to get the span. We're going to call it the piece, and we're going to save that into our puzzle code, our puzzle repository at the very top up here. And the reason we're sticking that in the repository up there is because we're going to have other routines here and here that are going to handle the mouse moving and the mouse up, which will be the moving of the mouse and the release of the mouse button itself. And so we need to be able to save what piece we're actually moving, and that's going to be saved within the puzzle piece. We're going to add a class called dragging, and that class is just basically changes the cursor to something called grabbing. So you'll see the cursor change from a simple hand to a little closed hand as we drag it, and we'll remove that once we drop it. We'll remove that dragging, or that grabbing cursor, or I'm sorry, remove the dragging class to go back to the normal cursor, which is the grab cursor. It's no big deal here. Here's the really important stuff. We're going to a document event, add event listener for mouse move to a routine called do drag over. This is going to handle every time we move the mouse. And then we're also, once we do the mouse up, we're going to do it on do drop. Now, notice we're doing it on document. Now, why are we doing it on document? Well, the reason I did it on document is I found out that, let's say if I wanted to automatically go outside of the board, strange things started happening when I did that. And so that kind of freaked me out. But I realized if we just did it with document and then did some very simple calculations to figure out, hey, if you've accidentally tried to drop it outside of the drag area, we can easily bring it back into the drag area. So if we can, once we refactor this thing, we may want to try to take a look at and try to take a look at this and make sure that we can maybe just get it on just the board instead of the document. But for right now, the document worked the best. So we're doing the mouse move on the drag over. On the mouse up, we do a do drop. But notice also we have a once equals true. That basically means here that once this event listener has executed, remove the event listener automatically. And we do that so that we don't start just compounding event listeners on top of event listeners on top of event listeners. We want to clean ourselves up here. We don't want to have any kind of memory leaks. Here's something interesting I noticed. Let's bring back up the code. Let me just, hopefully I haven't screwed something up here. Okay, so here's what's something that's going to be very interesting is that when I was playing around with this thing, I noticed that as I dragged and dropped the spans, sometimes it would go over one of the spans and sometimes it would go underneath the span. So for instance, I may drag this piece right here in the upper left hand corner and it may go underneath this sky piece but over one of these other two pieces. And the reason that was happening is that everything had the same Z index. So I needed to be able to bring the Z index of the currently dragged object to the forefront so that it would always be the top object. And the easiest, fastest way to be able to do that is basically by setting, and actually I just realized we did that wrong. Zoop. Okay, is by basically incrementing what I'm calling the rolling Z automatically, and then saving it over as this piece of the style index. So what will happen is that we will increment it, and we'll change the Z index of the piece that we're moving, and so it will always have the largest one because the next time it comes in, we're going to increment it again. And again, and again, and again. Yeah, so if you try to do 10,000 moves, your Z index is going to be 10,000. But the idea here is that whatever is your current span that you're moving, it's going to have the largest Z index, so it will always be on top. So that's why this rolling Z is what that is all about. Way up here. That's what that rolling Z is all about. So We got the rolling Z done. Let's take a look at the do drag over. This will be, again, the routine that will tell us what to do when we're doing a drag or when we're moving the mouse. So we get the piece. We get that from puzzle.piece. There are two options called movement X and movement Y, which is the difference between the X and the Y movement of the mouse since the last time that there was a mouse move event. So instead of getting the absolute position of the mouse, I'm getting the different, what has actually changed. Then I'm getting the offset left and the offset top, and all I'm doing here is I'm just adding it to the left and the top of the piece. That's it. That is all you really need to do, because that basically means that no matter where I grab it, as long as I move it, it's going to say, okay, I've moved 10 to the right and 1 down, so I need to change 10. I need to add 10 on the left and add 1 to the top. And that's all there really is to it. It's no big deal. All right, let's go ahead and now do the do drop here for the mouse ups, because what's going to happen when we drop it? Well, the only thing we want to do when we drop it is that we want to be able to just drop it, but then clean ourselves up. And through the magic of television, there's our code. Real simple. I'm getting the piece, the board width, and the board height from the puzzle. And the reason I'm doing that is that since we're doing the move on the document, I can move the piece outside of the board area. If I do move it outside, I want to move it back to where it could be, so where it should be. So what I'm doing here is that, first of all, I'm making sure that I'm setting left and top. I'm checking the left and the top first. So the left is, first of all, I want to get the maximum number of 0 or the piece offset left, because the offset left and the offset top is going to be the current position of the piece offset to where it is on the board. So if I am off the board, both left and top, or one or the other, or both, are going to be negative. And so by doing the math max, this will basically say, okay, if left and top are already, if offset left and offset top are negative, I'm going to make sure left and top is set to 0. Otherwise, I'm going to set it to the offset left and the offset top, which means it is still on the board somewhere. That's great. That will take care of it if it's moved off the top or if it's moved off to the left. Well, what about if it moved off to the right or moved off to the bottom? Well, that's real simple again too. Again, we're going to change left and top. All we're doing is we're taking now the minimum, the math minimum between the board width and the piece offset width and left. And basically what that will do here now is that, let's assume that the left from this particular number right here, let's assume that the left was 1,000. Well, of course, I know that 700 is my limit on the X. So what we have here is that the furthest right that a puzzle piece can be would be the board width, which in this case is 700, minus the offset width, which will be 125. So that is what? That's 575. So I know 575 happens to be, and this is just in this example here, 575 is the width, is going to be the furthest right I can push a puzzle piece before any piece of the piece goes off the board. So if that is, if my number here is greater than this, then I'm going to set it to this. Otherwise, I'm going to set it to keep it with left. And then do the same thing at the top. So this takes care of if it goes off to the left-hand side too far. This takes care if it goes to the top too far. This takes care if it goes to the right too far. This takes care if it goes off the bottom too far. And so then I just hit style and left. Since I'm dropping it, I'm removing the dragging class, so it doesn't have the little grabbing anymore. It just lets it go. But the big thing here is I'm removing the event listener. And I'm doing that because, notice, I got to keep the event listener active at all times while the mouse is down. But once the mouse is up, I don't care about it anymore. I don't want it to run this anymore. So I am removing that from the event listener. And again, it's just a way for cleaning us up. So technically that should now take care of us. We should now be able to grab a span and move it around the board. So let's save. Let's bring it up. Select our image, sample JPEG, go. Let's see what happens. Yep, I'm moving it around and it looks like it's going to move on top of everything. And then if I do this, yep, see, even that went on top of that. If I do this, that went on top of those. So my Z index is also still working. Well, how about the up, down, left, and right if we go off the board? So let's go off the top. Ah! Perfect. Let's go off the left. Perfect. Let's go off to the right. Perfect. Let's go off bottom. Perfect. Works like a champ. So that's really all there is to it. We've got the basics now for starting to do some of the unit tests. The only thing we don't have right now is how to combine the two. But what we're going to do is we're going to write the unit test next to be able to basically get it to where we can select any kind of cuts or any kind of shapes or anything like that. Although right now I'm going to kind of still keep it at a minimum number of cuts and a minimum number of cut designs. And that should basically all that should. Oh, one thing I do want to do here. We didn't do select number of pieces and select cut design. Let me show you what the dialog looks like. This is something that's added to HTML, but nobody ever uses. There is actually in HTML5 now a dialog element that you can put in there to be able to basically put a form within a dialog. And this form within the dialog, as long as the method says dialog, it will treat that form as if you did a form submission, but only submitted within the dialog. And it's very easy to bring up this particular dialog. Let me show you what it looks like. So our number of pieces is our ID. So what we want to do here is let's pop in some code to do the add event listener. There it is. The select pieces. Yeah, let's do that. Okay, so this is our select pieces. This is select pieces happens to be this ID right here. So when we click on this ID, it will do the select pieces. And what's happening? We're going to do number of pieces dialog. That is going to be number of pieces dialog. That is the number of pieces element by ID, so that's going to be this right here, number of pieces dialog. Good. So that's going to, where's the code? Where's the code? There's the code. There it is. So this is going to have, they're called a show modal. And of course, show modal is available because it happens to be that number of pieces dialog is an HTML dialog element. And this will show the actual modal. Now, how do we know when it's been closed and how do we get the value? Well, that's extraordinarily easy to do. So let's add in some more code here. This is the number of pieces dialog, add event listener, close. And that's it. Once it gets closed, that means the form within the dialog, and that's this form within the dialog, notice it has a method equals dialog, has been officially submitted. And so that will, once we get that submission, we first of all take a look at if the return value is equal to OK. And what's that return value? That return value happens to be whatever a button is that has a value. So I got a button in here for a value of cancel and a button here for the value of OK. When I click on any one of these buttons, that automatically does the form submission. And so I just have to take a look at cancel or OK and be done with it. So if it happens to look at OK, there is a value parameter that is that I can grab, and this is coming off of the, whoops, I just messed that up. This is coming off with the selected number of pieces. What is selected number of pieces? Selected number of pieces happens to be my selected number of pieces ID, which selected number of pieces happens to be this simple select. So I'm just grabbing the value of the select as it has occurred. And we got one routine that we need to add in there. Show number of pieces. And what the show number of pieces does is that's just something that allows me to be able to change the number of pieces and see it on the screen. That's all that is right there. So let me show you what that looks like. Then we got that saved. The select number of pieces. So that's what the dialog looks like. Notice we had a little bit of a backdrop kind of appear, a little overlay appear. And now I've got the select here, and I can select whatever. I can click cancel, and that will, as you can tell, it didn't change anything right there. Here's where the number of pieces will appear. So let's select 16, and let's click OK. Number of pieces is 16. Let's select 4. And click OK. Number of pieces is 4. So that's how the dialog works. And this is something I just recently discovered here, so I'm kind of want to play around with it and see what kind of styling you can do with it. If it's like the select button, you may not be able to do a whole lot of styling, but hey, it's there, so maybe there's something that can be done with it. But this will end what we need to do on this video, because we basically now have, let me just bring up the page one more time here. Select image, sample, go. So we basically now have everything we need to be able to at least start with the unit test or make sure at least this part works. So after we do that and get that code written, and then we're going to do the really hard part to start getting the pieces, get them when they get close to each other, start combining them until we can get one single puzzle. And at that point, we will be done. So that will finish up this video. We have basically got everything that we need to now start doing unit tests. Thank you very much for watching. If you like this video, please click on the like button below. If you wish to keep informed about new content, click on the subscribe button. And as always, please leave a comment below. I'd love to hear from you. Again, thank you very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.